Ms.Mariam. Assalamu alaikum, dear students. This is Cambridge Physics 5054 course, and I'm your teacher, Rafique. As you know that we are studying chapter number 3, that is forces. And the topic today we're gonna discuss is friction and its effects. Now, before getting into the core concepts of this lecture, I would like to share some learning outcomes so that after this lecture, you will be able to understand the friction is a force that impedes motion and produces heating. Discuss the effect of friction on the motion of a vehicle in the context of tire, surface, road conditions, including skidding, braking force, braking distance, thinking distance, and stopping distance. So first we have to understand that what is friction. Suppose you decide to ride a skateboard, you push off the ground and start moving. According to Newton's first law of motion, if no other forces are acting on your skateboard, you will continue to move. But what happens? Your skateboard slows down because of friction, and friction is the force that opposes motion between two surfaces that are touching each other, or you can say they are in contact with each other. So the amount of friction depends on two things. Number one, kind of surface. And number two, forces pressing the surface together. Now we have to discuss the types of friction. There are four main types of friction, and they are static friction, sliding friction, rolling friction, and fluid friction. Now, what is static friction? This is the friction that exerted on an object when it is at rest. Sliding friction is the friction exerted when an object slides over a surface. Rolling friction is the friction that exerted when an object rolls over a surface. And the fluid friction occurs in liquids and gases. But the points you have to keep it in your mind is sliding friction is slightly less than static friction, and rolling friction is less than sliding friction and static friction. Now we have to see that what causes friction. Even though a surface may look smooth, if you magnify the surface, it isn't smooth. So everything is made of molecules, and the molecules come together to make bumps. Some surfaces have molecules that leave large bumps and some leave smaller bumps. But all surfaces have bumps, and microwells occur when two bumpy surfaces are rubbed up against each other. They stick together. So the greater the force on the object, the greater the force of microwells. And the greater force is needed to overcome the microwells to move the object. Now, friction plays a very important role in our lives. And without friction, we would not be able to walk, run, or move about. So friction has both positive and negative effects in our lives. Here we will discuss some of them. Negative effects of friction are reduce the efficiency of cars up to 20%, causes wear and tear of moving parts in engines, motors, and machines. There are also some positive effects of friction. For example, needed for walking or holding a pair of chopsticks, and used in braking pads to slow down cars. Friction as a negative force we have to see first that the wheels of a shopping trolley. Most of us would have used a shopping trolley at the supermarket before. Now imagine, without the trolley wheels, we would be pushing and lugging a huge metal basket around the supermarket instead. We would need to exert a great deal of force to overcome the friction between the basket and the floor. So the wheel is an ingenious invention, and its circular shape reduces friction to a minimum. With less friction, it means we can move the trolley by exerting only a small force to overcome the friction beneath the wheels. Ball bearings. Another invention similar to the wheel in reducing friction between surfaces is the ball bearings. Ball bearings are commonly used inside machines, and they are small, smooth metal balls placed between the moving parts of a machine. They roll around so that parts of the machine do not rub against each other directly. Ball bearings can be found in the wheels of cars, bicycles, and skates. Lubricants and polishing surfaces. A layer of lubricant like oil or grease between surfaces can greatly reduce friction. For example, lubricants are frequently used between the moving parts of an engine. With less friction, the engine can last longer. Same is the case with polishing. Polishing a surface to make it smooth also helps reduce friction, as there will be less surface irregularities. For example, the inside surface of an engine are usually polished to reduce friction. Today's advanced technology has enabled us to separate moving surfaces with a thin layer of air between them. The hovercraft and magnetic levitation trains, the vehicles that are designed to float slightly above the surface to reduce friction, and this helps them to move faster. Friction as a useful force, we have to see first car tires. Friction plays a very important role in the motion of a vehicle. Without friction, a vehicle will not be able to move, as the tires will just spin around at the same spot. A vehicle traveling on a road with little friction may skid and lose control. Slippery road conditions on a rainy day can reduce friction greatly. It is extremely important that under these conditions, car tires are able to grip the road properly to prevent skidding. Therefore, they are designed with treads, grooves that channel water under the tire into them, and in this way, the tire is able to grip the road surface well. Parachutes. A parachute works by harnessing air resistance, a type of friction in air, to oppose the force of gravity, as an open parachute has a large surface area and it helps provide enough air resistance to slow down the fall of skydiver. The skydiver will then be able to descend safely. The next one is rock climbing. Rock climbers need to grip the rock surface well with their hands and feet in order to climb a mountain. Chalk powder is usually used to improve their grip. Now we have to see that what is skidding. An automobile skid is an automobile handling condition where one or more tires are slipping relative to the road. and the overall handling of the vehicle has been affected. Subtypes of skid include fishtailing, where the vehicle yaws back and forth across the direction of motion. Stopping distance. In an emergency, a driver must bring their vehicle to a stop in the shortest distance possible. So we can say that stopping distance is equal to thinking distance plus braking distance. Now, to understand that what is stopping distance, we have to see individually that what is thinking and braking distances. Thinking distance. Thinking distance is the distance a vehicle travels in the time it takes for the driver to apply the brakes after realizing they need to stop. Braking distance is the distance a vehicle travels in the time after the driver has applied the brake. So the braking distance of a vehicle can be increased by poor road and weather conditions, such as gravel or wet or icy roads, less friction between tires and the road. Poor vehicle conditions, such as worn brakes or worn tires, less friction between brakes and wheels. More mass in the vehicle, extra passengers for example, the braking friction has to work for a greater distance to remove the larger kinetic energy. And when a force is applied to the brakes of a vehicle, there is work done by the friction between the brakes and the wheel. And this reduces the kinetic energy of the vehicle, slowing it down and causing the temperature of the brakes to increase. The faster a vehicle travels, the greater the braking force needed to stop it in a certain distance. A greater braking force produces a greater deceleration. Large decelerations may cause the brakes to overheat, and the driver may also lose control of the vehicle. Now, what is reaction times? Reaction times vary from person to person, but are typically 0.2 second to 0.9 second. A driver's reaction time can be affected by tiredness, drugs, alcohol, and any kind of distractions. So longer reaction times increase the thinking distance when stopping from a given speed. So there are different ways to measure reaction times. One simple method involves dropping the ruler between someone's open thumb and forefinger. The higher the reaction time needed to grasp the falling ruler, the further the ruler falls before being stopped. The ruler can be adjusted to measure in seconds rather than in millimeters. So we can conclude that stopping distance is what? That is thinking distance plus braking distance. So you can suppose that a child runs out, driver sees a child, and driver thinks to stop. So he put his foot on the brakes will work, and car will stop. Now we have to see that how does friction affect the braking distance of a car. When the brakes are applied, the car loses kinetic energy. It means you can say that it slows down. The kinetic energy which is lost is transferred actually to the brakes and the wheels, which both get hotter. If the brakes are not seriously worn or malfunctioning, then the friction between the brakes and the wheels is very good because of modern brake design and materials. The most important friction for stopping a car occurs between the tires, the road surface. And if the road is wet or icy, then the friction is reduced and the braking distance is increased. So, if the brakes are applied with too much force, the tires will slide on the road surface that we called skidding. And on a wet road, the treated on the tire makes water on the surface of the road go up into the grooves, and then the water is thrown out sideways to get it out from under the tire. And if the tread is not deep enough, the tire cannot remove surface water quickly enough, and the tire will ride up on top of the water and lose contact with the road. That is called aquaplaning. Now this is the time for assignment. Here is a think pair share. For example, you have to think about that, is skidding kinetic or static friction? What is the braking distance of a car? And how do you control a skidding car? What are some examples of useful friction? And what is the average human reaction time? Thank you so much. Good luck.